I am project manager for VR and AR, so in the industrial direction. So my job is to find a lot of use case to use these 2 or 3 technologies and to have a nice return of investment regarding the use of technology. So the presentation is in French, so I hope you have your augmented reality glasses to translate automatically. No? Sorry for that.
Maybe in 2 years,
maybe.
3 years.
So don't worry, I will try to speak English. And so I will explain to you how we have used virtual reality to enhance our industrial development and how now it is in our DNA. And for every project we use now VR, and we have more and more use cases. But the first use cases was industrial development. Okay? So for beginning, a little video about the view of Safran regarding the factory of the future.
The world of aerospace manufacturing is changing profoundly. Technologies that were science fiction a generation ago are reality today. These breakthrough technologies, combined with the passion of our talented people, are the foundation of Safran's factory of the future. This revolutionary factory is designed to meet the growing demands of our clients for improved competitiveness, faster and more agile production, and better quality than ever before. So how does it work? Let's take a closer look. The factory of the future is more automated and autonomous. It maximizes the use of machinery and runs 24/7 with no need to increase operator engagement. This automation relies on machine connectivity and data continuity that boosts production efficiency, with data being saved and analyzed for continuous improvement. Cutting-edge technologies also dramatically improve manufacturing and production processes. Additive manufacturing enables the fast, precise creation of complex geometric pieces by adding layer upon layer of material. And non-destructive controls benefit from new techniques like thermography, ultrasound, and digital radiography to guarantee compliance of parts and materials. Cobots work with operators to reduce painful tasks while helping increase quality and flexibility. And numerous robots also help enhance productivity. Disruptive technologies like virtual reality and augmented reality transform how people work, from performing ergonomic tests in simulating processes to learning and executing complex tasks. While breakthrough technologies make the factory of the future possible, humans remain at its heart and soul. In their new roles, our high-tech operators will be able to monitor production systems via tablets and smartphones, freeing them to focus on high-value tasks. At Safran, we proudly harness technology and machinery to satisfy quality, reliability, and speed.
Little music at the end. So, as you can see, virtual reality and augmented reality is really part of the factory of the future, and that's why Safran has decided to work on these 2 topics. So today the topics is VR. So like that. So just briefly, Safran is a big international group in 3 domains: aeronautics, space, and defense. We are the number 3 in the aeronautics industry. We are more than 58,000, but now with Zodiac we are 92,000 of employees. We have some numbers here, but the most important thing is that we are an R&D factory group, we spend a lot of money in R&D, so especially in our field but also in new technology. So we have bought Zodiac Aerospace, I will say last year, to become the second mondial leader in aeronautics equipment. And so now we are able to provide not an aircraft, but quite. So from the cockpit to the thrust reverser and so on, so we are able to provide a lot of equipment for the aerospace industry, and that's where Safran Nacelle is here. So Safran Nacelle is the nacelle manufacturer. So what is a nacelle? The nacelle is the part which is around the motor, but it's not just carénage or a cover. It helps the sound reduction of the motor. It helps to brake the plane where you do the landing. So it has a lot of functionality in a reduced space and so on. So we are 3,800 person, and we work through. We have a design department, integration department, and also service or MRO department. And here is what is a nacelle for those who don't know. And we are based everywhere in the world and able to cover all the area. So here are the planes which have the nacelle installed on it. And now VR project for Safran Nacelle. So the VR project, just a definition, but you know what is VR. VR is a projection at scale 1 of 3D parts, and the objective for us is to explore and manipulate objects, tools, and things before it exists. So if you have one word to take back, is just to anticipate. We want to anticipate. And why we want to anticipate in our industry is to have the first time right. First time right, no error. Everything is ready when we have said it is ready. So we save time and we save money by managing this first time right. So the origin of the project is we have a cycle development for a previous program, which was the A320neo, which was 60 months. And we have to do the same things for the A330neo, less, but the same thing minus 18 months. So we have to work on several things to anticipate, to do better and better and better. And we have decided to work on virtual reality. So our need was to anticipate, understand the ergonomics, and also in VR we can enhance the collaborative work. We want to integrate it in our process. It's not a nice tool in a corner, but a tool which will be used by everybody. And it's also a level of changing management. So how we have decided which solution we have to use. We have done a lot of, I would say, discover sessions, and still today we are still doing that, because we really need to, I will say, vulgarize what is VR and explain to people what is VR. And we have done a lot of brainstorming with all the tools, a lot of questionnaire to have a feedback of every users. And here are the needs of Safran Nacelle. It's training, it's, I will say, workshop layouts, industrialization of a program, ergonomics, maintainability, and so on. But these are the main topics. And now, which type of material? So, as you may know, in VR there is different type of material. So either you have to stay here. I want to move. Either you have a power wall. So power wall is just things like that, and it's quite okay. Then power wall plus a ground, a corner, a 4-phase cave, and a 5-phases cave, which is mainly used by I will say Airbus or Renault, and but it costs a lot of money. And then you have the HMD. So, and regarding that, we have also made a little constatation and some findings, but it's not our own findings. I'm sure it's yours also. It's more you have faces in the virtual world, more it's immersive and less you can share with other people. But less you have faces, more you can share, more you can do collaborative work with I will say 10, 20 people in a meeting. So that's why we have also in our studies try to put the level on which type of tool we want. Either we want immersive tool or either we want a collaborative tool. Because it's not the same use cases. For collaborative, it's great to do, I would say, collaborative engineering. It's discussed with different type of, I will say, profiles, production profiles, logistic profiles, health and safety profiles, and everybody will be able to share their experience, their needs, and then go in the same direction and find the right decision to take. And it will help for the first time right. And then you have the immersive work, which is quite okay for trainings, for example, or just to validate your own data, your own work. So our needs was very centric on the collaborative work, but we have a little bit need for immersive work. So that's why we have decided to invest in a 2-phases cave, in helmets, and also to use the software ICIDO, because the industrialization was fast, the ergonomics was very interesting, the kinematics also. A lot of 3D formats were okay. The immersion was very fast. It's just a drag and drop of the 3D files and it's okay. So that's what we are looking at in our industry. The interaction with the model, with the 3D model is quite okay, and we can track real object in the real world, and we can also do some collaborative work between our different factories in the world. So it's also something very interesting for us. We are industrial. We are not graphics developer, IT developers, so we wanted to have a tool quite easy to use or something which talk to industrial guys, because we are using, I will say, CATIA. CATIA is the base for us. So if you use CATIA, you can use this software very easy, very quick, and so on. So it's not something very for the change management of the profile of the people who use virtual reality. It's just a continuity. My grandfather was using a desk table. My father was using a 2D, I will say, software. I have beginning with a 3D software, and now I use virtual reality to design my parts. So it's I will say, a normal evolution with the evolution of the technology. So here, what we have in our plant. So it's a two faces cave, and here you have one of the first sessions we had, so people can share and so on. So now, since then, we have decided to do a lot of things with VR. So thanks to that, in 2016, so we have our first virtual reality room. In 2017, we have the Grand Prize of Innovation in Safran. So the innovation was not VR, but the use of VR in our industry. It's because everybody can use VR like we have used VR to get the first time right. And then we were on the aerospace salon and so on. But now we are trying to find other use cases. It's like health and safety trainings. It's like I will say aircraft company trainings to do the maintenance of our product. It's also to have the finger tracking, the full body tracking. So finger tracking is when you try to track your hand and to have some very precise movement. Full body tracking is instead of moving the body of your mannequin for ergonomics like Pinocchio, it's just put things on you and you will be tracked as in the cinema industry, and the mannequin will do your own movement. So it's quite more easy to find the correct animation, but I'm sure you will have a lot of demonstration regarding this kind of technology in the main booth, but this technology, we are trying to look after that. 3 minutes, okay, I will speed it up. So the first use case was the A330neo, so we have validated all the toolings to functionality, work instruction, ergonomics, accessibility. We have also developed all the workshop layouts to see all the logistic flow, to anticipate every, I will say, big buildings, accessibility, and diverse things. But as I have explained, it's a really nice tool to do the change management. You can share with everybody, with everything, and it will help you to make things understandable by everybody. So that's why when you come in a real life, everybody was agree on what will happen on the field, and everything was okay at the first time. And thanks to that, we have won a lot of time and a lot of money. And now it's just a question, so not a question, but it has to be. Virtual reality is not a nice tool in a nice room. It's a nice tool to be used in our processes. So we really have to do that.